How can we find a percentile for a normal distribution? The scores of a reference population on the Wechsler Intelligence Scale for Children, WISC, are normally distributed with a mean of 100 and a standard deviation of 15. A child scored 92 on the WISC. What percentile does this score represent? The first thing we should do is we should label our normal curve. We know that the WISC scores are normally distributed with mean 100 and standard deviation 15. That means the center of our distribution is 100. One standard deviation below the mean will be 85. Two standard deviations below the mean will be 70. One standard deviation above the mean is 115. Two standard deviations above the mean is 130. Our child scored 92 on the test, and we want to know what percentile does that observation correspond to. We want to know what percentage of children score below 92 on the WISC score. In order to do this, we need to compute the z-score for that value. Remember, the z-score tells us how many standard deviations above or below the mean a particular data value falls, and the formula is x, the data value, minus the mean divided by the standard deviation. So for this problem, we will have 92 minus a mean of 100 divided by a standard deviation of 15. This corresponds to a z-score of negative 0.53. This child scored 0.53 standard deviations below the mean on the WISC test. We needed this z-score in order to calculate the percentile from a standard normal table. Everything has to be standardized in order to use the standard normal table. We are now ready to go to that table. Here we have a standard normal table. We want to look up our z-score and find the area to the left of that z-score. This z-table only gives data values for positive z-scores, but we can use the symmetry of the normal distribution to answer our question. So instead of looking up a negative 0.53 z-score, we will look up a positive 0.53 z-value. And we see that the area to the left of a z-score of 0.53 is 0.7019. In our normal curve, we have our z-score of 0.53. The area to the left of that is 0.7019, which leaves 1 minus 0.7019, or 0.2918 above 0.53. Which data value or z-score are we really interested in? We really want the negative 0.53 z-score. Because of the symmetry of the normal distribution, we know that the area to the left of negative 0.53 is the same as the area to the right of 0.53, which is 0.2981. This z-score corresponds to the 29.8 percentile for the distribution. So a score of 92 on the WISC corresponds to the 29.8 percentile. Before completing this problem, let's do the percentile calculation on the calculator as opposed to using the standard normal table. There is a command on the calculator called normal CDF. If you give it a lower bound and upper bound, it will return the area between those two numbers for the standard normal distribution. So for our problem, we want the area below our z-score, which was 92 minus 100 divided by 15. So we want the area between negative 10 and our z-score. How do we choose negative 10? We just want a number that is at least 3 standard deviations away from the mean, because recall, 99.7% of all area under the normal curve falls within 3 standard deviations of the mean. So let's do this on the calculator. If we go to second vars, down to number 2, normal CDF, do -10, comma, and we're going to use our z-score of 92 minus 100 divided by 15, and we see that this corresponds to an area of 29.7 below our z-score, or a 29.7 percentile. We could have also done this problem without converting to the standard normal distribution first. If we do normal CDF, lower bound, upper bound, mu sigma, this will return the area between the lower bound and upper bound for a normal mu sigma distribution. So rather than converting to the standard normal distribution, we could have done normal CDF 30, 92. So we want the area between 30 and 92, our score of 92. Again, 30 is chosen so that you're more than 3 standard deviations away from the mean. A mean of 100 and a standard deviation of 15 on our distribution. So again, go to second vars, down to number 2, normal CDF, enter parameters 30, 92, a mean of 100, and a standard deviation of 15. I typed that wrong. I have a mean of 10. Let's go back and redo that problem. Second vars, normal CDF, our lower bound of 30, an upper bound of 92, a mean of 100, not 10, and a standard deviation of 15. And again, it gives us the area of 0.297 to the left of 92 and our normal 115 distribution. And again, we see that the percentile corresponding to 92 is 29.7. And our problem is complete, either using the standard normal table after we standardize our distribution, or using the calculator either through standardization or from our original distribution.